Hi, this is Joy Zeigler welcoming you to the Exam 1 review for Math 310. This is Part 1. In this first problem, we're given 2 points and we're supposed to find slope. So we use the slope formula, which is that the slope equals y2 minus y1 over x2 minus x1. So in this case, doesn't matter which one are x1 and x2 or y1 and y2, it just means that you keep the ordered pairs consistent. So let's make 2 and negative 5 to be x2 and y2, and then this will be x1 and y1. Okay, so we start with y2 minus y1 over x2 minus x1. So we've got a lot of negatives to mess with. The easiest thing to do to start with is to say that minus a negative is plus a positive. Those minuses sort of cancel out. So now we're looking at negative 5 plus 9, and negative 5 plus 9, when you have a negative and a positive, you find the difference of the absolute values, and the difference of 9 and 5 is 4. And then you give it the sign of the largest number. Well, the largest number is 9, and that's positive, so 4 is positive. In the bottom, you're just adding two positive numbers, 2 and 4 is 6. So you have 4, 6, and if you enter 4, 6 into your exam, you will get it wrong. And that is because 4, 6 is not reduced, so you don't have the slope until you have the most reduced form of the slope. So we can see that 2 goes into 4 2 times, and 2 goes into 6 3 times, and that is how I got that m is equal to 2/3. In this problem, we're given a slope and we're given a point, and we're asked to find a line. And the way we do that is we use the formula for the line, that is the point-slope formula. We're given a point, given a slope, we use the point-slope formula, which is y minus y1 equals m times x minus x1. So y minus, and then y1 is the y part of the point we're given, so y1 is minus 2 equals m, which is 2/7, and notice that this y stays y, and this x stays x, but the y1 and the x1, that's where you substitute in the point you're given. So the x value of the ordered pair that we're given is 2. Okay, so now we change the negatives to positive there. We don't have to do anything to the negatives on the right side of the equation. So we have y plus 2 equals 2/7 x minus 2/7 times 2. Now when we multiply a fraction times a whole number, you should write the whole number as that whole number over 1. So instead of writing 2, I'm writing 2 over 1, because now I can multiply those fractions. First, to multiply these fractions, let's just look at this. First, I look to see if there's anything we can cancel in the numerator and the denominator. There is not. So then the second step is just multiply the numerators. 2 times 2 is 4. Multiply the denominators. 7 times 1 is 7. And that's your new fraction. So we have y plus 2 equals 2/7 x minus 4/7. Okay, our goal is to get y equals mx plus b. We don't have that yet because we have y plus 2 equals mx plus b essentially. So we have to get rid of that 2. Let's subtract it from both sides. Okay, so we're going to end up with y equals 2/7 x minus 4/7 minus 2. Now let me draw a little line there so we don't get confused about what's what. Okay, now if you look at the right side of the equation, you have an x term and then you have some numbers. You can't combine the x and the numbers, so the x term, 2/7x, it's done. We don't have to simplify that any further. But the minus 4/7 minus 2, well, we can combine those numbers. Now when you add or subtract fractions, you need to have a common denominator. And even though 2 isn't a fraction, 4/7 is a fraction. And the same is true of whole numbers. So first we're going to change the whole number to a fraction. But we have negative 4/7 minus 2 over 1. We're dealing with this part here. And negative 4/7 minus 2 over 1, we do not have common denominators. So to get a common denominator, we are going to multiply the 2 over 1 by something so that we get 7 in the denominator. And that something's going to be 7 over 7. Because if we multiply 2 times 7 in the numerator, we get 14. And if we multiply 1 times 7 in the denominator, we get 7. And obviously we could reduce that to 2, but our goal right now is not to reduce it, it's to get that common denominator of 7. So let's rewrite what we have now. We have y equals 2/7x minus 4/7 minus 14/7. Okay, so now we can combine the numerators. We have 2/7x. Now when you add or subtract fractions and they have the same denominator, then you keep the denominator and you combine the numerators. Okay, now notice what we're combining. We're combining minus 4 and minus 14. So essentially we are saying this is plus, I'm going to do a little extra step here, plus minus 14/7. So what I'm showing you here is that if you subtract a fraction, it's the same thing as adding the negative of that fraction. In fact, that's the definition of subtraction. It's adding the opposite. So I only do this because when I go to this step and put everything over 7, I want to have minus 4, and then I can have minus 14 or plus negative 14, that doesn't matter. But this is correct. 2/7x plus and then minus 4 minus 14. It wouldn't be minus 4 minus 14. So that's why I changed addition to subtraction, or subtraction to addition. So we have 2/7x plus, and then that would be minus 18/7. Okay, and we can't simplify 18/7, so we can go ahead and rewrite that as subtraction, 2/7x minus 18/7. And that is the equation of a line. Now I want to go back for a minute to what I did right here, because people always get confused about this. Why did I change a minus to a plus? And so let me show you that. What if we had gone straight from here to rewriting it as y equals 2/7x minus 4 minus 14 over 7. Okay, so I didn't change anything to pluses. I just kept that minus sign out in front, and I put 4 minus 14 over 7. Well, it's not going to be correct, and here's why. You're going to get 2/7x minus 4 minus 14 is negative 10. And so minus a negative 10/7 is plus a positive 10/7. So you have 2/7x plus 10/7, and that does not equal what our actual answer is. And the reason is, when we combine the 4 and the 14, and we pull that minus out in front of the fraction, what we're saying is that minus applies to both terms here, both terms, this minus is applied to this 4, and that's correct, but it's also being applied to that 14, and that's not correct. And so by changing that minus to a plus, a negative, plus a negative, then we're careful not to make that mistake with a negative. So I just can't urge you enough to go ahead when you combine fractions that you're adding or subtracting, to go ahead and change your subtraction to adding the opposite. So you're, instead of subtracting a positive number, you're adding a negative number. And if you do that, that will keep you safe and let you handle your negatives okay. In this problem, we're given 2 points and we're supposed to find the slope of the line. And now I can tell you just by looking at those 2 points that this slope is going to be undefined. The reason that's true is that the x values are the same. And so, you know, when we talked about functions, we said that if you have one x value, your input is your x value, your output can't be different for the same x value. And in this case, we have 2 different y values for that one x value. So that's one reason it's undefined. The other reason is when you use the slope formula, you subtract the x values in your denominator, right? You have y2 minus y1 over x2 minus x1. But if x2 and x1 are the same value, then your denominator is going to be 0. And that is just not allowed. You cannot have 0 in the denominator or you'll get an undefined value. So let's go ahead and do it. y2 we'll say is negative 8 minus 4 over negative 17 thirds minus negative 17 thirds. And we have our minus a negative is plus a positive. So we have negative 17 thirds plus 17 thirds, and that's going to equal 0. And on top we have negative 8 minus 4 is negative 12. And there we have it. We have a fraction with 0 in the denominator, and that is a big, whopping undefined. Okay, sometimes we'll be given an equation of a line and we have to manipulate it a little bit to get it in slope-intercept form, which is y equals mx plus b. So what we want is y equals mx plus b. But we don't have that. We have 3y equals mx plus b. So let's get rid of the 3, and we're going to do that by dividing everything by 3, and that gives us y equals negative. Now notice what I'm going to do here. X over 3 is the same thing as 1/3, and then you can pull x out to the side, plus 7/3. Okay, voila, we have y equals mx plus b. So let me write that again. So m is our slope, and m corresponds to negative 1/3. That tells us that m is negative 1/3. What is the slope of the line y equals 4? Well, is that going to be a horizontal line or a vertical line? The line crosses the y-axis at y equals 4. So it's going to be a vertical line. It's going to look like this. Here's our axis, and we'll say this is 4, and so our line goes like this. So that's y equals 4. It's a horizontal line, and we know that the slope of a horizontal line is 0. And when you're not sure, you have to think of a roof. If a roof is flat, it has 0 pitch to it. The rain won't run off it because there's no pitch. So that's 0. But if the roof stands up on its end and doesn't cover the ceiling at all, that just doesn't make sense. So that's an undefined slope when the roof is standing straight up and down vertically. So a horizontal line, the slope is 0. And we know that y equals 4 is a horizontal line because wherever this line is horizontally, y is equal to 4. So 4 is right there, and it's also y equals 4 for all of these different values of x. So it has to be a horizontal line. You are now ready for part 2 of the Exam 1 review.